Well, hello class, this is Mr. McAllen again, and today we're going to do day 2 of our um, flipped classroom, and this is where we're going to be going over trig functions. But one of the things we should do first is let's establish if you guys know how to use Pythagorean theorem. We want you to find the length of the hypotenuse. So take a minute, copy this down, and try to figure out what the length of the hypotenuse is. And remember, on the SAT, you'll always be given a diagram that looks like this, and they'll say Pythagorean theorem is a squared plus b squared equals c squared. Make sure when you're done you have simplified radicals, just like we did in last night's homework, and check your answer. I'm going to pause the video right now, and when you unpause it, you'll see the solution. Okay, everybody. I'm unpausing the video, and as you can see here, the two shorter sides given were 4 and 7, and the longest side is always hypotenuse. So when you use Pythagorean theorem, it's 4 squared plus 7 squared equals h squared. You get Pythagorean theorem written down, and you solve for the height, the hypotenuse, and that would be root 65. So let's see if root 65 can be simplified. That equals root 5 times root 13. And there's no way to simplify it, so we just leave it as root 65. So moving on to trigonometric ratios. The objective for today is to introduce the 6 trig ratios. And we would like you after this video, if you were given two sides of a right triangle, we want you to find the third side and all missing trig ratios. So I'm just going to highlight those objectives. So we want to go over the 6 trig ratios, and if given two sides of a right triangle, find the third side and all missing trig ratios. So let's move on. Starting out, we have the old rule SOHCAHTOA. Now, SOHCAHTOA is a way we remember the 3 basic trig ratios. One of the things that's really important is understanding where to pick the angle. So if I ask you for the sine of alpha, circle the angle alpha, and now the 3 sides of the triangle should be easily defined. The hypotenuse is always the longest side. The opposite side is the side opposite that angle, and the adjacent side is the side right next to that angle. Just to talk about one other way we could do this, if I asked you what is it relative to theta, if we weren't talking about that, our hypotenuse would still stay the same, and our opposite and adjacent side would switch. So because these ratios over here are in terms of alpha, that's the angle that the book has chosen for us to use for this problem, we're going to talk about opposite and hypotenuse for sine, adjacent hypotenuse for cosine, and opposite and adjacent for tangent, and that will be with reference to alpha, the angle at the top. So I'm going to write down based on this, since the SOHCAHTOA stands for the sine of an angle is equal to opposite over hypotenuse. That's where you get the SO from. The cosine of alpha is equal to the adjacent over the hypotenuse, and the tangent is equal to the opposite over the adjacent. And that's why we have these little acronyms here to help tell us what the 3 ratios are. So in this question right here, because the sides are labeled, we have 12, 5, and 13, and alpha is a reference angle. What we're going to say is that alpha, or the sine of alpha, is the opposite of alpha, which is 5, over the hypotenuse, which is 13. That would be the sine. The cosine would be the adjacent side, which is 12, over the hypotenuse, and the tangent is the opposite side. Remember, opposite is across the triangle, that would be 5, over the adjacent, which is 12. So those would be your 3 ratios that you would give. Now, let's talk about the other 3 trig ratios. Cosecant, secant, and cotangent. Let me give you their definitions in terms of the other trig ratios. Cosecant is always 1 over the sine ratio. Secant is always 1 over the cosine ratio. And cotangent is 1 over the tangent ratio. So how are you going to remember what these ratios and how they're what they go with? And there's a little device that I like to tell my students about, that when you look at the word cosecant, the abbreviation, I'm just going to circle a letter. It would be, if you look at the first or second letter after the start of cosecant, you see it's an S. And that tells you that has to do with the sine ratio. This is like a memorization device. It isn't really anything mathematically sound. There may be lots of other ways to remember this, but this is one way that helps students. When you see the secant ratio, the way you know that that goes with cosine is you look at the letters following the S. It's not E because we don't have an E ratio. So you look at the C, and that tells you that it goes with cosine. And then the last one, cotangent, you don't use the O because there's no ratio with an O in it, but you look at the last one, the letter T, and that it could remind you that this one is a reciprocal of the tangent ratio. So there are lots and lots of ways to memorize this. Some people just write them down and use flashcards. I like to use the lettering of the ratio to help me figure it out. So when you do the cosecant, if they ask for the cosecant of alpha, you know it goes with the sine ratio. So because the sine ratio of alpha before was 5 over 13, you know it's a reciprocal for cosecant, so you would say 13 over 5. When you have the secant ratio, you know that that deals with the reciprocal of cosine. And cosine from before was equal to 12 over 13, so the secant ratio is just a reciprocal of that. And the last one for cotangent, it's just the reciprocal of the tangent ratio, which was 5 over 12 before, but now the cotangent is a reciprocal, which will be 12 over 5. So hopefully that helps you square that away. And there are a couple things I'll show you in class tomorrow that can also help you remember it. But this is one of the ways that a lot of kids in the past have really enjoyed working with this. Our next example brings us to another right triangle. This is one that I would also write down besides the ratios from before. They give us information about the tangent of alpha. Draw the right triangle and label the angle alpha and the two sides that the trig ratio gives you. So if you were to set this up, you first want to pick, because it's a right angle, you always draw on the right angle symbol. Remembering that the tangent ratio, they give us a ratio of 3 root 3 over 3. It's always good to simplify your ratio before you start working with it, so I'm going to simplify this ratio. The tangent of alpha is equal to root 3 over 1, because the 3's cancel. You may not realize this, but once they give you a ratio of sides for the tangent, you know what an opposite side value could be and an adjacent side value. Because remember, tangent is opposite over adjacent from the saying SOHCAHTOA. So because I know my opposite side is root 3, if I draw my angle alpha to be there, I'm going to put the opposite side to be root 3 on this side. I'm going to make my adjacent side to be 1. Now, people may ask, why didn't you make the hypotenuse 1? The ratio is opposite over adjacent, and the adjacent side is never the hypotenuse. So I'll just cross that out. And now in order to find our other 6 trig ratios, we need to figure out the hypotenuse. So this is a right triangle trig problem. Remember using Pythagorean Theorem on any triangle, A, B, and C, we'd have A squared plus B squared equals C squared. So I'd like you to try that with these sides and solve for the hypotenuse again, and I'm going to pause the video. Now if you look at the problem, if you found the third missing side, we've actually done part of example 3. Using Pythagorean Theorem, you had one side was 1 squared, the other side was root 3 squared. And when you did Pythagorean Theorem, you found out that c squared equals 4, or the c value, or hypotenuse, was equal to 2. Now in this problem in example 3, example 2 and example 3 are really kind of combined. It says to find the missing side and then find the 6 trig ratios. So what we're going to do is I'll just zoom out, and since we have the sides now, we should be able to find all 6 trig ratios. Notice tangent is already complete because that's what they gave us. So the sine of alpha is, because it's opposite over hypotenuse, you're going to look for the opposite sides being root 3, and just put divided by 2 because that hypotenuse is 2. For the cosine, it's the adjacent side. So that would be 1 over 2, which is hypotenuse. Now notice I've lined up sine, cosine, and tangent to be with their reciprocal trig ratios. So that makes things easier if you line them up this way, because once you find your 3 trig ratios, you really have your 6 trig ratios. So I'm just going to do the reciprocals. And remember that when you have a ratio that has a radical in the bottom, we should rationalize it. From the work last night, when we rationalize, you multiply top and bottom by the rooted number, and we end up getting for this ratio 2 root 3 over 3. This one doesn't need to be rationalized, but this one does, and when you do this one, the cotangent will be equal to root 3 over 3. So hopefully you found this example helpful, and now we'll move on to our next right triangle trig problem. In this example, they give us a trig ratio again. They say the sine of alpha is equal to 0.5. Draw the right triangle. It's already drawn. Label your angle alpha. Remember, it's never going to be the right angle. So I'm just going to put alpha here. Find the missing third side, then find the other 5 trig ratios. So when they gave me the sine ratio was equal to 0.5, they were really giving me a fraction. And as a result, I know that the opposite side and the hypotenuse, I know their values. One value is 1, that's the opposite. Hypotenuse is equal to 2. I need to find the third side. So I'm going to use Pythagorean Theorem. Using Pythagorean Theorem, remember this time we have our long side. So that'll be 2 squared. That equals, we'll call that B, 1 squared, plus my unknown side, A squared. And this will be, I'll just label that A for now. So when we solve, A squared equals 4, and I'll move the 1 over the other side. So A is equal to root 3. So I'll just write root 3 here, and now I'm ready to do my 6 trig ratios. The sine of alpha is equal to, as they gave me before, 1 over 2, opposite over hypotenuse. And I'll label this opposite, this hypotenuse, and this adjacent, just because it's all relative to that angle, so I don't mess that up. The cosine of alpha is equal to root 3 over 2, and the tangent of alpha is equal to 1 over root 3, which, remember, that should be rationalized, and that will end up being root 3 over 3 once you rationalize that ratio. The last problem is to do it with secant. Just like we did before, they ask us to draw a right triangle. They ask us to find, label the 2 sides that we're given and find the third, and then find the other 5 trig ratios. So, because they gave me secant of theta is equal to 4 over 1, I also know that that's related to cosine of theta is equal to 1 over 4. So now I know because cosine ratio is equal to the adjacent over the hypotenuse. So I'll have a 1 here for the adjacent side. That's adjacent. Hypotenuse is 4. And now I need my opposite. So using Pythagorean Theorem, I have my unknown, I have 1, and I have 4, and I just would say 1 squared plus x squared equals 4 squared, and then I would solve for x squared equals 16 minus 1. X squared is equal to 15, or x is equal to the root of 15. So my opposite side is root 15. So now find my 3 trig ratios, the 3 regular ones. The sine of theta is equal to the opposite over the hypotenuse. The cosine of theta was sort of given to us. It's 1 over 4, the adjacent over the hypotenuse. And the tangent is equal to root 15 over 1. If you want to find the other trig ratios, the three other, cosecant of theta, notice I line that up with the sine because these are reciprocal. This is just 4 over root 15. The secant ratio, which was given to me, is 4 over 1. And the tangent ratio, I'll just find the cotangent of that by flipping this fraction. It's 1 over root 15. And all you would have to do to finish this problem would be to rationalize these fractions. It looks like I've exceeded the video length. I told you this would not be over 15 minutes, but we're at 16, and hopefully you've had a chance to look this over, and maybe you put my playtime on you increased my voice to 2 times, so we move through this bit quicker. Make sure you take notes on certain key features of this, and I hope you have good questions for me for tomorrow.